explain. Now, equilibrium means if a body is at rest, or if it move with a constant velocity. If it move with a constant velocity, or if a body rotate around an axis with a constant angular velocity, those are in equilibrium. It means now when something is in equilibrium, there is no linear acceleration. That linear acceleration is zero. And there is no angular acceleration. That angular acceleration also zero. So if a body is in equilibrium, there is no linear acceleration, there is no angular acceleration. It means if a body is in equilibrium, the resultant force or the algebraic sum of the forces should be zero, and there is no angular acceleration means no resultant torque, or the algebraic sum of the torque should be zero. Right? So if a body is in equilibrium, it should satisfy these two conditions. These two conditions. So let's write down under the equilibrium. Therefore, linear acceleration also zero, angular acceleration also zero. Now we are going to study the equilibriums of the body under some condition. First, equilibrium under two forces. So write equilibrium under two forces. So if a body is in equilibrium under two forces, it has to satisfy the two conditions. One is the summation of the force should be zero. The other one, the summation of the torque should be zero. To satisfy the first condition, the two forces should be equal and opposite. Two forces should be equal and opposite. And to satisfy the second condition, their line of action of force. Their line of action of force should be lie on a one line. They should be collinear. So if this is F1 and if this is F2, F1 should be equal to F2. And they should act as shown in figure. So draw this and write down this. Coming equilibrium under three forces, three coplanar forces. So equilibrium under three coplanar forces. So in that also, first we are going to study equilibrium under three coplanar concurrent forces. Now, when there are concurrent forces acting on a certain body, let's say this is the object and these are the three forces acting on that object. So their line of action of force should meet. Now we have to satisfy the two conditions. First one is summation of force should be zero. The second one, summation of torque should be 0. To satisfy the second condition, they should not make any torque. Therefore, their line of at a one point. So the third force should be lie, so that the line of action of force of that third force also should meet at the same point. And now let's assume these forces are F1, F2, and F3. And to satisfy the first condition, the resultant of any two force should be equal and opposite to the third force. So if I found the resultant of these two force, and if it is R, that R should be equal to F3 and it is opposite to the F3. The line of action of that R should lie should lie on the same line of the F3, right? So so then the equilibrium under three coplanar, yes, sorry, it is coplanar force. Now the three parallel force. So then something is to be in equilibrium under three coplanar parallel forces, that resultant of any two should be equal and opposite to the third force. That is the same condition. And that third force lie between that the other two forces. Their line of action of force lie in between the line of action of the other two forces. So here F1 plus F2 should be equal to F3, right? Now in order to make summation of force 0, that F1 plus F2 should be equal to F3. In order to make summation torque 0, that line of action of F3 should lie between the line of action F1 and F2. So these three forces are in equilibrium. They are parallel coplanar forces. Now this is the fixed point. You have to find the F3 value and the distance to the F3 value from the fixed point. F3 is equal to the addition of these two, so it is 30 Newton. And now when taking the moment around O, now let's say if I select the clockwise direction as positive, then now this 10 Newton made an anti-clockwise moment, and the distance to that 10 Newton is 2 meter perpendicular distance. So it is minus 10 into 2. And the 20 Newton also made an anti-clockwise moment, so it is minus 20 into that perpendicular distance from the fixed point is 4. And F3 now made a clockwise moment, and now it is 30 Newton. So it is plus. So momentum made by 30 Newton is 30 into x, perpendicular distance, and since these are in equilibrium under these three forces, the resultant torque should be 0. Therefore, I have to equal this to 0. Now then, I have to subject the x. Now, after solving, you are getting an x value of 3.3. 3.3 lie between 10 Newton and 20 Newton. The distance 3.3 is lie between 10 and 20. So, in order to be in equilibrium, that force should lie in between them. System given in figure is in equilibrium. You have to find the mass M and the reaction R. So here now equilibrium, that torque around any point should be 0. So I select point to be considered, then I take the moment around that point with taking clockwise direction as positive. Now this 2 kilogram made 20 Newton force. Let's say this made a force mg. Then the moment made by 20 Newton is a clockwise, so it is positive. Then it is 20 into 0.2 meter. And the mg made an anti-clockwise, so it is negative. It is capital Mg into 0.3 meter. And there is no any other moments. R does not made a moment around O. So these are the only moments made. So I equate that to 0. Then it gives mg equal 20 into 0.2 over 0.3. By that you can find the mg. And now when I take that summation of force should equal to 0, the forces acting on these are R and mg and 20. If I select the upward direction as positive, then R become plus and mg become minus and 20 also minus, and the summation should be equal to 0. After finding mg, I can find the R value. It is equal to mg plus 20. If a certain body is in equilibrium under some forces, then that forces should be made a closed polygon. Now, if we draw those forces in a certain scale, they should made a closed polygon, because that summation of force should equal to 0. So if a body is in equilibrium, the forces act on the body can be represented by a closed polygon. Now the figure shows a certain system is in equilibrium. Now these are the forces acting by the masses. You have to find the R1 and R2. Now, when I apply the first condition, when I apply the first condition, the summation of f equals 0, I can write now, if I take the upward direction as positive, that R1 plus R2 minus 20 minus 100 minus 30 is equal to 0. By this you can get that R1 plus R2 is equal to this 20, 30, 50 and 150. If I apply the second condition, that summation of torque at around any point 0, I can select any point of this system. Now I select this point as x. So I'm going to take the moment around x, taking clockwise as positive. Then now this 100 Newton made a clockwise moment. So it is plus 100 into 5 perpendicular distance. And the R2 made anti-clockwise moment around x. It is minus R2 into perpendicular distance is 10. And the 30 Newton made clockwise moment around x. It is then plus 30 into perpendicular distance from the x is 15. And this 20 Newton made an anti-clockwise moment around x. So it is minus 20. The perpendicular distance to the 20 is 5. And since the resultant torque is 0, I can equate it to 0. So by this, I can find the R2 value, and by substituting the R2 for this this equation, I can find R1.